Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CPET, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. We have been seeing the basic concepts programming in C. The last session we had seen the basic elements that are available in C, the way C was designed and the way to program using C. Today we will look at the data types that are available in C. So as we get an introduction to the data types, what is actually data? Data is any raw information which can be represented using numbers or characters. A programmer needs to identify the right type for the right data. If it is a number, it has to be identified that way, and if it is a character or some text, it has to be given that kind of an identification. C compilers support a variety of data types that we will be seeing in the future presentations. The data types are classified in C as integers and characters. Integers are nothing but numbers, as we all know, which do not have fractions. So the further classification of integers is short integer, long integer, signed integers and unsigned integers. In characters which represent text, we have signed characters and unsigned characters. Now this float and double represent the fractional numbers. Now we will see in detail what are the characteristics of each of these data types. So when we consider integers, we have the short integer. Now the characteristics can be studied as the memory space they occupy, the range of values they represent, the effect they have on the program execution. So when we see the memory allocation for a short integer, it occupies 2 bytes in memory, which is equal to 16 bits. So this is the smallest memory space that can be allocated to represent a digit in C. Now what is the meaning of this word range? Range represents the lowest possible and the highest possible value that can be represented using this data type. So a short integer can represent values between minus 327.68 to plus 327.67 and all the values that come in between. Program runs faster when we use short integers. Now how is this? We know that whenever we have to execute a program, we have to allocate memory for that. And every time we require a data, it has to be taken from the memory and it has to be executed. So when the memory space that is allocated to a data is less, the memory access time will be less. So the time it takes for program execution will also be less. Obviously the program runs faster. Now the same characteristics when we see for a long integer, we see that it occupies almost double the memory space. A short integer occupies 2 bytes, whereas a long integer occupies 4 bytes in memory, which is equal to 32 bits. So it can represent bigger numbers. So if you will see the range of this long integer, the lowest possible negative value is also very high and the highest possible positive value is also very high. So this long integer is used only in exceptional cases when we have to represent very large numbers. And obviously the program will run slower because when we define a long integer, it obviously means that it has to access more amount of memory. Now the next characteristic of a short and long integer as we see is something called a format specifier. A format specifier is nothing but a prior indication to the C compiler about what type of data it has to scan or take as input and what type of data it has to print. It is a representation to the C compiler about the type of data that the program is going to handle. So %d and %i are used to represent short integers, whereas %d alone is used for representation of a long integer. And then we have the example to represent a short integer. We see we can either give it as int a is equal to 2 or short int b is equal to 15. Now if you see, by default when we give int, it means a short integer. If we have to specifically use a long integer in the program, then we have to go in for this keyword long. So here we have the keywords short as well as long. These are the keywords that are to be used when we represent integers. So this is the difference in the way we handle data using integers based on the size that is required for the representation of a digit. Next we move over to signed integers and unsigned integers. Now if we will see the characteristics of signed integers, they occupy the same 2 bytes in memory, they represent the same range of values as a short integer, their format specifier is also %d and %i, and in signed integers we have another classification called long signed integers. So as the name suggests, it is used to represent a wider range of values and it occupies obviously more bytes in memory. So this is the example for a signed integer which is represented as int a is equal to 2, and if it is a long signed integer, it has to be given as long int b is equal to the value. So here again by default an integer is considered to be a short signed integer. When we consider unsigned integers, obviously we will not be considering whether it is a positive or a negative value. So the memory allocation is the same for this, but if you will see, the range of positive values that can be represented by this is almost double that of a signed integer. This is because the negative values are totally eliminated and the number of values that is represented as negative is added to the positive side. So if you will see the range, it is 32768 plus 32767 all moved to the positive range of values. That is why its range is up to 65,000 on the positive side. The format specified for an unsigned integer is %u, and when we have long unsigned integers, the same thing applies again. The range is almost double on the positive side because the negative values are totally eliminated over here. An unsigned integer holds only positive values. And this is the example to represent or to use an unsigned integer in a programming language C. We have to specifically mention the keyword unsigned, shorten C if it is a short unsigned integer, and if it is a long unsigned integer we have to mention unsigned, long and the variable name. Now these are the types of integers in C that we have seen: short and long, signed and unsigned, short signed and long unsigned. Now next we move over to characters, where we have again signed characters and unsigned characters. If we see the same characteristics, it is again a character occupies 1 byte in memory and its range is from -128 to +127. Because it is a signed character, it has to represent both the negative as well as the positive values. The format specified for a character is %c, and this is the way you declare a character in C. When we move over to unsigned characters, it occupies the same memory space. Its range is double on the positive side, adding 128 to 127. Its format specified is %c, and it is represented as unsigned character is equal to the character that you want to assign. Now if you will see, these are characters. Now why are we specifying the range in terms of digits? This is because every character has its ASCII value. For example, we know that when we give the number 65, it represents capital A. So each of these digits represent only a character in the ASCII table. So that is the reason these characters ranges, the minimum and maximum possible characters that can be represented by a character data type in C are given in the terms of digits. Next we have floats and doubles, which are nothing but data types in C to represent fractional values, that is decimal points. So first we will see the float data type. The float occupies 4 bytes in memory, which is almost double that of a short integer. And the range of a float is expressed in the exponential form that we have seen in the last session, where the exponential form comprises of the mantissa and the exponent. So if you will see, the range is specified in terms of the decimal values. The format specified for a float is %f, and this is how we declare a float data type in C. Now the difference between the range of an integer and that of a float is that when we say the range of an integer data type, it means the lowest minimum value and the highest maximum value, and it is also used to represent all the values that occur in between these two. But in the case of a float or double, the range represents the lowest minimum and the highest maximum value that can be represented, but there are certain values in between these two that may not be represented by the float data type. So, that is the difference when we use the same term range for an integer and for a float or double. So, when we move over to double, it occupies 8 bytes in memory, which is double that of a float, and the range is also almost twice the values that can be represented by a float, and a format specifier is %LF, which stands for long float, because if you see, double is nothing but a long float. Twice the amount of memory that is required for a float is required for double. And in double itself, we have the data type long double, which occupies 10 bytes, and this range is also much higher than that of a normal short double. And the way to declare a double is using double Y. Now, this double and long double values are generally used in exceptional cases in very large applications where large numbers need to be represented. Normally, when we write general programming operations in C, we go in for the usual integer data types, or when we use fractional values, we go in only for float. Obviously, because they occupy less memory, which makes programming faster, and the execution result is delivered at a much higher speed. So, this is about the data types that are available in this programming language C. Now, this type conversion is another concept associated with these data types. Now, type conversion is nothing but when we want to explicitly convert from one data type to another. Now, why is this required? Why during programming we have to convert from a data type to another? Now, this is the reason why a programmer will always like to display the value of a variable the way he wants it. And when this is an example, when we divide 5 by 2, the actual value, the result is 2.5. But if you will see, the result will come only as 2. The fractional value will be automatically eliminated by the compiler when it displays the result. Now, the reason for this is that if we see the two operands that are being operated upon, it is 5 and 2, both of which are integer values. So, the compiler will understand that because we are dividing only integer values, that we want the result also as an integer. That is the reason, though the answer is a float, that is a fractional value 2.5, it will eliminate that fractional part of 0.5 and it will display the result only as 2. Now, in such a situation, if we want the whole float value of 2.5 to be displayed, we have to give it in this form. In the statement which prints the result, we have to explicitly give the keyword or the data type to which we want the answer to be converted, and then we have to perform the operation. So, if you see the example, it is a printf statement which displays the result, and we are saying that we are dividing two integer values 5 and 2. But if you see the format specifier, it is a format specifier for a float, it is %f, and we explicitly give within brackets the keyword float, and then we do the operation of 5 divided by 2. So, this is the concept of type conversion. Type conversion is nothing but conversion from one data type to another. So, we have data types to represent digits as well as characters, integers as well as fractions, and in that we have a concept called type conversion, which converts from one data type to another explicitly by the program. So, type conversion is nothing but a concept related to data types that enables a programmer to convert the data type from one type to another the way he or she wants to display it in the program. So, these are the data types that are available in C and the type conversion that can be done to represent the data the way the user desires. Now, let us go in for a short break and return afterwards. Welcome back after the break. As we have been seeing in detail the data types that are available in C, I will just give you a brief overview of the data types that we have seen. We can represent numbers as well as characters in C. To represent integer numbers, that is without decimal, we have integers and the types are short and long, signed and unsigned. To represent fractional numbers, we have float and double data types, and to represent text, we have signed characters and unsigned characters. Now, I will just give you a brief overview of the compilers and interpreters that are used in the C program. Normally we say that C is a compiled language, it is not interpreted. However, compilers and interpreters do the same work but in a different style. So, as we are going to study about compilers, let me also give you a brief idea of what an interpreter is. Both of them do the same job of converting the high level language that the user knows into a machine level language that the system understands. The difference is that the compiler compiles the entire program or translates the entire program in one shot at one time into the machine level language. Now, that is a very fast process, but the problem is a compiler will not compile the full program until the user clears all the errors in the program. So, say we have 100 statements in the program, when the compiler compiles it, we have around 50 to 60 errors at one time, which is very difficult for the user to read, find the errors and then to detect them, then to recompile the program and clear the errors. So, though it is a fast process, it is difficult for the user when he has to correct the errors. However, when we take an interpreter, it reads every line of the program and then it converts it. Now, that is the difference between the compiler and the interpreter. Now, interpreter is more time consuming, but when we see the user's point of view, it is easier to read, understand as well as modify. Now, next we move over to the structure of a C program. We already saw in the last session that C is a structured language. It has a starting, ending and a body. So, now let us see what is the main concept behind writing a C program. Every C program contains a number of building blocks we called functions. We used the term module in the last session to describe the word function. So, I said that a problem in C can be handled by dividing the problem into smaller subtasks, solving that specific task and then putting it together to get the entire solution. So, that is the concept of this function or module. It is one or more statements or a small set of statements that perform one particular subtask of the entire problem, and when you put it together in an organized manner, that forms the entire C program, and when you run it, it gives you the desired result. So, the another name for a function is a module. So, a C program is nothing but a collection of different modules or different functions which collectively solve the problem that we want to address. Now, this is the structure of a C program. It has these many sections in it. You have a global declaration section, a header file section, you have the main, which is the most important function in C, you have a declaration part, an execution part and the user defined functions, and in all these three parts you have something called statements. Now, we will see each of these in detail. When you consider the global declaration function, it is, as we all know, something that is globally available to all parts of the C program. So, variables, we have already seen what are variables in the last class. Variables which are used in more than one function in a C program. Normally, we use variable so that we can assign some value to it. And since C is a collection of functions, every function will have its own variables, which will not be visible to the other functions in the program. So, the global declaration of variables allows that single variable to be made visible and available to all the functions in the C program. So, generally by default every variable is not global unless you specifically declare it to be global. So, when a variable is to be used in more than one function, it is called a global variable, and this must be declared outside all the functions. If you declare some variable inside a function, it is called a local variable. Only when you declare it outside all functions, it can be visible to all the functions, accessible to all the functions, and it is called a global variable. Next, we have this header file section. Now, what is a header file? As we all know, a header file is something that gives the heading of a document. So, every C program begins with this header files. Header files contain the function definition. For example, if you see in C, we have all the data types which are permissible, we have the elements, the identifiers, the white spaces. So, all these symbols which are permissible in C have been defined in these header files. Every header file has an extension which is a must when you define a header file. So, every header file should have that .h extension. They have a predefined format which cannot be changed. and this is the way you declare a header file. You have to give hash, which is nothing but a delimiter, include, which is nothing but a keyword, then you have to give the less than symbol, within that you have to give the name of the header file, .h extension, give a greater than symbol. So, this is the normal way we use a header file, or you can use the double quote symbol instead of the less than and greater than symbol. So, either of these two formats you have to use when you declare a header files, without which compilers will never run your program, because without a header file, a C program will not know what are the data types permissible in C, what are the symbols permissible in C, it will not have access to any definition. So, the presence of the header file indicates to the compiler that you have to look into these particular files to know what are the symbols, what are the rules for framing statements in a C program. So, function prototypes and definitions are included in such header files which are to be used in the program. For example, stdio.h stands for standard input output. So, the printf and scanf statements are nothing but they are used in C to display the result and to accept data input from the user. Each of these statements has a definite format. So, unless a compiler knows what is the format for these two statements, it cannot say whether your program is having an error or not. So, where will it look for to see the correct format? It will look into the stdio.h header file. So, to tell the compiler that the definitions of the printf and scanf statements are present in the header file stdio.h, we have to include these header files in the program. So, if you forget to include these header files, the compiler will not know where it has to look for, and it will not be able to find out the definitions for those statements. So, it will simply say your program is having this error, your program is having this error, even though your program will not have any error. You might have been completely correct, but your compiler will not know how to execute your program. That is the importance of these header files. Without a header file, there can never be a C program. Next, we move over to this function main. Every C program must contain a main function. It is a starting point of the program. The execution of the program, the compiler always begins execution with this main function only. Now, in this main function, you may have other sub functions or you may not have functions. If the main is there, that itself forms a C program. Whether you declare other functions or not is up to your problem, it is up to the way you want to solve it. But without a main function, there can never be a C program. And program execution always starts with the opening and closing braces. After every main function, you have this opening brace, and then only the set of statements will follow. So, the compiler will check for the main function and an opening brace, only then it will begin checking whether your program is correct or not. Otherwise, the compiler will not know where to start the program execution. It can identify the main function only as the starting point of your program. Next, you have the declaration part. The declaration is where all the variables that are used in the program will be declared. That is, when we have to find out the volume of a rectangle or the area of a square, we need some values, isn't it? So, we have to declare variables to assign those values. Initialization of variables is when we assign some value to a variable. Say if you say side of a square, you have to say whether it is 10 centimeters or 20 meters or whatever it is. So, the value has to be given to the variable, that is called initialization. And initialization means, as I said, providing initial values to variables. So, all these are done in the declaration part of a C program. The executable part is where you actually perform the execution. If you have to find out the area, you have to do a square, and if you have to find out the volume, you have to do length into breadth into height. So, the actual processing is done in these set of statements, and we should always remember that this execution part should come only after the declaration part. If it comes before, the C program will not be able to identify whether the variables are correct or not. And processing can be done either in a single statement or a set of statements, that depends upon our problem. If it is a small solution, one statement is enough. If it is a big one, you need more than one set of statements, and they should always be enclosed between the opening and closing braces, as we have seen in the function main. Now, here comes the user defined functions, which, as I said, depends upon the user. According to his problem, he can define his functions. It is optional, mostly defined only after the main function. In certain cases, it may be defined even earlier, but normally the structure of the program the functions come only after the main. So, this is optional. If you want, you can define it before the main function, but that will make it more difficult for you when you have to go through the program and correct the errors. These comments are used in the C program. This is also highly optional, they are not necessary. Our comments are normally inserted by the programmer, because one person will write the program, another person may try to make corrections in the program. So, in that case, if he knows the comments that are inserted by the programmer, it will be easier for the third person to understand what the programmer has actually done. So, they are useful for documentation, so that even after maybe say 2 or 3 years, if you are going to see the same program, you may not remember at that time for what reason you wrote that program. But if you have these notes close to the statements, you will be able to identify, oh, for this reason this program was written. So, whether this program is applicable to my current problem. So, all these solutions you can derive quite easily. It is easier to understand the flow of the program. Comments are of 3 types. You have a single comment, you have nested comments, that is one comment inside another, and you have multi-line comments. That is, if you are going to comment only a single line documentation you are going to give, you can just start it and end it the way I have shown it. You have to give a / followed by a asterisk symbol, and at the end of that comment you have to give an asterisk symbol and close it with a /. If it is a multiple line comment, right at the end you have to complete it. Next, we move on to the programming rules that are available in C. I will just brush through this, because this is just something that you have to remember. They must all be in lowercase letters unless they are constants, like you yourself want to define something like max or sum. Unless it is something like that, all the C statements must be in short lowercase letters, because C is case sensitive. Blank spaces may be inserted in between, that we saw while we were using white spaces. They should not be used, blank spaces should not be used while declaring variables, keywords, constants or functions. It is not necessary to fix the position of a statement in the program. Once the compiler sees a semicolon itself, it will know that the statement is over. So, whether you put it on the same line or on different lines makes no difference. Opening and closing braces must be balanced, in the sense the number of opening braces must be equal to the number of closing braces. This is the final point of executing the program. You have 3 parts. One is where you create or write a program, you compile and link it, and finally you execute it. So, when you create a program, it is to be written the way we saw the structure of a C program. They should be written in the C editor, they should have a default extension of .c. Sometimes users are allowed not to give an extension or to give their own extension. So, say you are writing a program area, it should be area.c. Compilation and linking, we have already seen what is compilation. They must be translated to the object code or machine level language, and it is done after correcting each statement. Now, this is the point in compilation, you have to do it after correcting each statement. If there is no error only, compilation proceeds and it converts the .c file into a .obj file. If an error exists, correction is done and then compilation is to be redone. And linking is nothing but, as I said, in stdio.h header files, all the definitions will be there. So, the definitions are to be taken by the linker and the corrections have to be seen and they have to be converted into the object code and then loaded into the memory. Here there is one example, the power function. So, its definition must be brought from the math.h header file of the system. So, this is the work of the linker. Finally, you have the execution of the program, where the object code is loaded in the computer's main memory and the program is executed. Now, these are the questions that are available or that can be possibly asked in this session. The different data types in C, the difference between the characteristics of the data types, it may be signed, unsigned, integers or characters. The rules for writing a C program are very important, because unless you remember them, you can never write a C program. The functions of a linker is nothing but it has to get the object code of the program and load it into memory, get the function definitions from the header files. The different sections of the C program are what we have seen: the header files, the global declarations, main function, declaration execution, comments and statements. Compilation is nothing but conversion of the high level language to machine language. Type conversion is explicit conversion of data from one type to another. Now, this is a summary of the entire session. The different data types in C, the type conversion using the data types, the compiler and the interpreter and the differences between the two, the structure of a C program, the rules to be used while writing the C program, and the execution of the C program, the creation of the program, compilation and linking, and the execution. So, with this we complete the different types of data types in C and the way we have to write a C program and the rules to be followed while doing it. Thank you.